Hello guys, welcome back to my YouTube channel. So today I'm going to discuss with you the anomalous behavior of the beryllium. So in this lesson you will learn that the anomalous behavior of beryllium refers as exemplified by the formation of covalent compounds, and you can also learn that how to describe the diagonal relationship between the beryllium and the aluminum, and also you can also explain the similarities of aqueous beryllium salts to aqueous with the aqueous aluminum salt. So let us begin the lesson now. So this is the beryllium, and it is 2s2 orbital because because it has two valence shells, and this is the beryllium that we can see in our daily life. And the atomic number of beryllium is 4. That means that it has the electronic configuration of 1s2 and 2s2. So from this electron configuration, we can know that beryllium is a group 2 element. So from this lesson, we want to learn that how beryllium can have different behavior compared to other group 2 elements. So let us watch the next. So the features of beryllium. Beryllium actually have significant covalent character, while the other group 2 elements are ionic. That is because beryllium has the smallest size along group 2 elements. So from this periodic table, we can know that beryllium is the second period, and of course we know that it has the smallest size. So this results in beryllium has minimum screening effect due to the smaller size. And the minimum screening effect gives the nucleus of beryllium has the highest effective nuclear charge to attract the valence electron towards itself. As we all know, although going down to group 2 or going down to the group, the screening effect is actually decreasing, because as we all know, what is screening effect? So if this is a nucleus and this is the electrons, so as we all know, if the electrons is further away from the nucleus, that means that it has the higher screening effect. However, if the nucleus is very near to the valence electron, we can actually know that the atom has the smallest screening effect. So from this case, we can know that actually beryllium has the smallest screening effect when going down the group 2, because it is the smallest. So it has smallest screening effect. So its smallest screening effect gives the highest effective nuclear charge to attract the valence electrons toward itself. That means that beryllium has the highest ability to attract the valence electrons to itself. So yeah, this results in high ionization energy in the beryllium atom, because as we all know, ionization energy is the minimum amount of heat required for the atom or for the element to release its valence electron. So let us imagine, if beryllium is very attract to its valence electron, we can know that we need higher heat to release the valence electron. That's what that means, high ionization energy. So let's move to next slide. So this is beryllium ion. As I mentioned earlier, beryllium is actually the smallest, and it likes to attract the valence electrons. Hence, beryllium ion, Be2 positive, is can distort the electron clouds of the adjacent negative anion. That is because beryllium ion has high polarizing power and high charge density. So from this chart, we can know that beryllium ion has a high polarizing power because it can easily distort. So what is distort? Distort actually means attract. It can attracts the electron cloud of the anion easily because it has high charge density. So as we learned since primary school, we learned that when the electrons are distorted, they will form actually a region where the electrons are shared. This region actually show that this beryllium has a covalent character. So that's what that means. So now let's move to beryllium chloride. Beryllium chloride is actually a covalent compound, while the other group 2 elements chlorides are actually ionic compound. That is because beryllium is actually distorts the electron clouds. It makes there is a shared region between the ion and hence this causes it becomes a covalent compound. While the other group 2 elements they are actually ionic because they do not distort the electron clouds of anion easily because they has less polarizing power and less charge density. So as we all know, when we going down the group, the charge density of the beryllium will actually decrease. Yeah. So the beryllium chloride is actually non-soluble in non-polar organic solvents because this is the principle of light dissolves light. As we all know, covalent compound is a non-polar compound. Therefore, it can only dissolve in non-polar organic solvents. While the other ionic chlorides like magnesium chloride and so on, they are ionic compound. Hence, they can only dissolve in polar organic solvents. This is what mentions in the principle of light dissolves light. And beryllium chloride also exists as dimer in room temperature, which exists as Be2Cl4 due to the polymerization to form the long chain. So, beryllium chloride actually hydrolyzes exothermically by water and release acidic steamy white fumes. This is the equation represents the hydrolysis of beryllium chloride. So when beryllium chloride reacts with water, it will produce beryllium hydroxide, which is a new compound and also 2 hydrogen chloride. So this hydrogen chloride is actually the acidic steamy white fumes. Yeah, so this gives the acidic properties to the water when the beryllium chloride dissolves inside the water or when it reacts with water because it will produce the HCl which is acidic. Yeah. So as I mentioned earlier, the other group 2 elements dissolve in water without any observable change because they are ionic compound. This is a same like the principle of light dissolves light. So you must also remember one thing, which is beryllium chloride does not conduct electricity in molten state because it is a covalent compound. Hence, it does not have any ion presence in the molten state, which means that it cannot conduct electricity in molten state. However, you must always remember that it can conduct electricity in aqueous state because in aqueous state we have ions which can conduct electricity such as hydrogen ion and also hydroxide ions. So yeah, beryllium chloride only cannot conduct electricity in modern state because it is a covalent compound. So I think that's all from today's lesson, and thank you for your listening. If you find my video helps you, you can actually subscribe to my YouTube channel, and also don't forget to like this video. And thank you very much. Arigatou gozaimasu. Bye.